All right, so next we're looking at solving a matrix equation of the form AX is equal to B, where the elements of the matrix X are unknown. Essentially, these are the steps you would go through. You're starting off with AX is equal to B. Your objective is to determine the elements, the elements of matrix X. Now, how we'd go about this is, so what we need is we need to have X alone on the right-hand side, and then whatever is on the, X alone on the left side, and whatever is on the right-hand side is going to be equal to X. The process is there. I'm just talking you through it. The first thing I would do is I would multiply both sides of the equation by A inverse. So A inverse times A is equal to, A inverse times A times X is equal to A inverse B. Now, if you multiply a matrix by its inverse, you're going to get the I matrix. So this is IX is equal to A inverse B. And whenever you multiply a matrix by the I matrix, you're going to get back the I matrix. So you're going to get back the original matrix. So X would be equal to A inverse B. So because we know that this is going to happen in the middle, we don't do it. We know it's going to happen, so we don't do it. We know that this is going to happen in the middle, so we don't do it. All we do is we move from here, go straight to here. Which is to say, to solve a matrix equation of the form AX is equal to B, we simply write back X on the left-hand side and multiply B on the right-hand side by A inverse. So essentially, to solve a matrix equation of that form, here's what we do. We write back X on the left-hand side and multiply B on the right by A inverse. All right. And then after we multiply A inverse and B, we'll be able to determine the unknown elements of matrix X. All right, example 39. All right, so example 39 deals with solving simultaneously the system of three equations in three unknowns. So the first thing I'm going to do is I'm going to write this like a matrix equation. Write my simultaneous equation as a matrix equation. So as a matrix equation, I start off with the coefficients of X, the coefficients of Y, the coefficients of Z. So this is my coefficient matrix. That would be my matrix A. Then I have the matrix, the column matrix with the variables, X, Y, and Z. And this is equal to, over here, 4, 1, a column matrix of what is on the right-hand side. So now this is of the form A, X is equal to B. Our objective is to find the matrix X, determine the matrix X, and by so doing, determine the values of X, Y, and Z. Now, we've just established that to solve a matrix of this form, we need to write back X and multiply the right-hand side by A inverse. So the first thing we need to do is to find the inverse of A, which is my 3 by 3 matrix. So let's start out by finding the determinant, because we will Definitely need the determinant of A. So the determinant of A is equal to 4. The determinant of -1, 2, 2, 1, -1. The determinant of 2, 3, 2, 1, plus 3. The determinant of 2, 3, -1, 2. This becomes 4 -1 -4 -1, 2 -6 plus 3, 4 -3. This becomes -20 plus 4 plus 21. So, sorry. So the determinant appears to be +5. If I'm going to get the matrix, sorry, if I'm going to get the determinant, sorry, the inverse of A, I'm going to need the matrix of cofactor. To get the matrix of cofactor, I need the cofactor of every element in matrix A. So let's go through the process of getting that. First row, all right, so the sign convention is positive, negative, positive. -1, 2, 2, 1. Everybody should know by now the process by which you do about getting that. What you would do is that you would ignore all the elements in the first row and the first column and find the determinant of the matrix formed by the remaining elements. This becomes -1, -4, -5. Two, this is 2, sorry, minus first, -2, -6. This is 4, 2, 3, -1, 2. This is 4 -3, 7. All right. Let's just get the others here, put them here. A second row. So it's A2, 1, A2, 2, A2, 3. Sign convention, negative, positive, negative. One, two, three, 1, -1, -6. +5. 4, 3, 3, 1. This is 4 minus 9 minus 5. Minus 4, 2, 1, 3. Minus 8 minus 3 minus 5. The third row, sign convention, positive, negative, positive. 1 minus 1, 3, 2. 2 minus minus 3, 5. 4, 2, 3, 2 minus 8 minus 6 minus 2. And finally, 4, 2, 1 minus 1 minus 4 minus 2 minus 6. So the matrix of cofactor would be matrix of cofactor would be minus 5, 4, 7, 5, minus 5, minus 5, and 5, minus 2, minus 6. A inverse would be it's 1 over the determinant, which is what? 5, times the adjoint matrix, which is the transpose of the matrix of cofactor, minus 5, 4, 7, 5, minus 5, minus 5, 5, minus 2, minus 6. So now x, y, z would be equal to the inverse multiplied by the matrix B, which is 4, 1, 3. 1 over 5 minus 20 plus 5 plus 15. 16 minus 5 minus 6. 28 minus 5 minus 18. Up top, this is 0. Here is 5. Which 5? Yes. This is 10, and here is 5. So X, Y, Z would be equal to 0, 1, 1. Therefore, X is 0, Y is 1, and Z is equal to 1. All right, so for example 40, the first thing we're asked to do is to write these equations in the form AX is equal to B. A is the coefficient matrix. So my answer to A is this. 1, 2, 7, 1, 1 minus 4, 1, 3, 1. That's A. X, Y, Z. This is X. And B is 3, 6, 4. The next thing we're asked to do is that we're asked to find A inverse. So this is A, X, and this is B. We're asked to find A inverse. Everybody knows A inverse. So this is B is equal to 1 over the determinant of A times adjoint A. That's A inverse. For A inverse, I need the determinant. So let's find the determinant. The determinant of A is 1, 1, 3, minus 4, 1, minus 1, 2, 3, 7, 1, plus 1, 2, 7, 1, minus 4. So the determinant becomes 1. This is 1 minus 12 minus 1, 2 minus 21 plus 1 minus 8 minus 1. This becomes 13 plus 19 minus 9. So something is wrong. Oh, this was supposed to be 7. So this is 7. So this should be minus 15. So this is going to work out to be 17. So the determinant is 17. It's 15. The determinant is 17. In order for me to get the adjoint matrix, I need first the matrix of cofactor. For the matrix of cofactor, I first need the cofactor of every element. So let's start with the first row. Second row. Third row. Sign convention, positive, negative, positive, negative, positive, negative, positive, negative, positive. This is the determinant of 1, minus 4, 3, 1. So this is 1 minus 12. This is 13. This is 2, 1, 3, 7 minus 2 minus 21. This is 19. Two, 7, 1 minus 4. This is minus 8 minus 7 minus 15. All right, of course, for the second row, first element is here. We're going to block out the row and the column and find the row and the column containing the, so it's the second row and the first column. Block out those and find the determinant of the remaining matrix. That's how we get the cofactor element. So it's going to be minus 1 minus 4, 1, 1, minus 1 minus 4. This is minus 5. One, 7, 1, 7. 1 minus 7 minus 6. 1, 7, 1 minus 4 minus 4 minus 7. This is positive 11. One, 1, 1, 3. This is 3 minus 1, 2. One, 2, 1, 3. Minus 3 minus 2 minus 1. Lastly, 1, 2, 1, 1. 1 minus 2, 1. So the matrix of cofactor um, 13, 19, minus 15, minus 5, minus 6, 11, 2, minus 1, 1. A inverse one over the determinant of A, which is 17. Adjoint A, and adjoint A is the transpose of the matrix of cofactors. Transpose means you're interchanging the rows and the columns. So 13, 19, minus 15, minus 5, minus 6, 11, 2, minus 1, 1. Now, x, y, z would be equal to A inverse times the adjoint times matrix B, which is 3, 6, 4. All right. So let's just multiply and end this. All right, so minor corrections. This should be a negative here. And so should be a negative here and should be a negative here. All right, now when we multiply, we're going to get 1 over 17, 39, minus 30, 8, plus 8. We have 57, minus 36, minus 4. We have minus 45, plus 66, minus 4. We have 1, 17. This is 17, 17, 17, which is equal to 1, 1, 1. So therefore, x is equal to 1, y is equal to 1. So remember, x, y, z here, and z is equal to 1. All right, so, and this here should be minus 1. All right, that's it.